Hi, for the people that were not here in class, this is the next lesson, combination and permutation. You have time, you can read this, pause it whenever you want. But a fruit salad is a combination of apples, grapes, and bananas. In reality, when you go buy a fruit salad, I don't think we mind in which order they put our fruits in. So at that moment, when the order does not matter, it's called a combination. You need to write this for your notes. Who knows, you might need it later. A combination, for example, to a save. If the number is 472, I bet you that if you try 724, it will not work. All this time we thought it was called a combination, but in reality, in math, it's called a permutation. Why? Because the order matters. Even in the password of your computer, your phone, if you don't put it in the right process, right number, it will not open. So that's why it's called a permutation. In order to solve these problems, first, you gotta know which one's which. When I give you the problems and the word problems, make sure you can identify them. But I gotta go over factorials first. Factorial is this. Just means to multiply a series of descending natural numbers. I'm gonna try to make this video long, so here we go. For example, 5 factorial. 5 factorial is just this. 5, because it says descending natural numbers, so I gotta go down all the way to 1. Do not go to 0. If you go to 0, it will just be 0, so 5. The next one that is descending before 5 is 4 times 3 times 2 times 1. So my answer, which is multiply it. 5 times 4 is 20. 20 times 3 is 60. 60 times 2, 120. That is what a factorial is. That's when you see an exclamation point like this one. Another example. 4 factorial. 4. You start with that number. 4 times 3 times 2 times 1. And then just multiply across. 4 times 3 is 12. 12 times 2 is 24. Times 1 stays the same, so 24. That is what a factorial is. I can do all sorts of problems with factorials. I can multiply them. I can pretty much divide them. So let me do one with a division. Let's do 7 factorial over 4 factorial. Always expand the bigger number. So if you want to expand the bigger number, 7 times 6 times 5, times 5 times 4 times 3, and I'm just going to do dot, dot, dot like this. Why? Because this is the shortcut. You already have a 4 in the bottom, so 4 times 3, you know you're going to go all the way to 1. So all these numbers are going to cancel. There's no reason for me to write it. So 7 times 6 times 5, if you got a number in the bottom, just pretty much cancel the thing and just multiply. 7 times 6, 42 times 5, that will be your answer. So you just multiply across. Let me get my calculator so I can make sure I am right. So you just multiply across. 7 times 6 times 5. I got 210. So when you see an exclamation mark, you just multiply across until you get to 1. Unless you got something to divide here in the bottom. If you got something to divide, you just cancel the thing out. Example 1. Make it bigger. Suppose that you can invite 3 friends to go to a concert. But what do you know? You have 5 friends. So you don't want to be in that predicament of who do you invite. You don't want to pick favorites. So what do? You're going to put all the 5 names on a bowl. You want to know how many ways are there to choosing three people. Again, you want to be fair with your friends. So at that point, you got to decide, is it combination or permutation? Well, I told you about the definition. If the order doesn't matter, it's called combination. If the order matters in which I take the papers, then at that moment it becomes permutation. But because I'm not choosing my favorite friends, the order doesn't even matter then. So when the order doesn't matter, it's called combination. Again, when the order doesn't matter, it's called combination. Here's the combination formula. N CR. N factorial. N minus R factorial. R factorial. You may wonder what this means, so I'm going to give them to you. Let me put them in a different color. N is this. This one doesn't even work. Total number I can choose from. So the N, total number I can choose from. On this side, the R, number I can select. So my total number I can choose from. Well, how many friends do I have? So it's going to be 5. Combination, my R. Out of those 5, how many can I select? Well, I can only take 3. Now I'm just going to replace them with my formula. It's asking for N. So N will be 5 factorial. On the bottom, there's another N. So it'll be 5 minus, what is the value of R? 3. Again, what is the value of R? R factorial. That's why I was teaching you how to expand this thing. Now I just need to simplify. 5 factorial over what's 5 minus 3. And then I didn't do nothing to this one, leave it alone. Now it's a matter of expanding the thing. So 5 times 4 times 3. I am stopping at 3. Because if I keep going, this one's going to do the same thing. 3 times 2 times 1. So they're all going to cancel. There's no need for me to keep writing unnecessary things. I took care of the 3. Now I got to take care of the 2. So 2 times 1. 5 times 4 gives me 20. 2 times 1 gives me 2. My final answer equals 10. That is when you are using the combination formula. This is when you use the combination formula. Since you're in a video, I don't need to wait on you. But if I were you, I would come and actually pay attention in my class. After this week, I will no longer do videos for none of you. Nah, let me rephrase that. I will keep making videos, but they will not be as detailed as my class. The next one. How many ways will we get first, second, and third place winners in a race of 4 people? Like I said, you always ask yourself, does the order matter? If it doesn't matter, it's called a combination. If it matters, it's permutation. But well, let me ask you this. If you're in the Olympics, don't you want to be in first? If that cannot happen, I bet you some of you won that silver. So this problem, it matters to someone. So at that moment, it becomes a permutation. A permutation is this. And PR. The only thing that changes is the P in the middle. That gives you the clue, the hint. Hey, I gotta use the permutation formula. And the permutation formula is this. N factorial, N minus R factorial. Notice it looks the same. The only difference doesn't have an R at the end, which makes it more complicated. If you get confused in any of the formulas, then I will get you on that. My test will happen next week. The only thing I need to do is solve it. So value of n. What is the total number I can choose from? Well, there's 4 people, so I got 4. Out of those 4, how many am I selecting? Well, I need the first, second, and third place, so 3. Value of n. Oh, you still don't get it. This is where I get the value of n. This is the value of r. So n equals 4 factorial on the bottom. 4 minus 3. Simplify. 4 minus 3 should give me 1 factorial. But what do you know? I gotta go all the way to the bottom. So 4 times 3 times 2 times 1. And I go to 1 because this is 1. This cancels. So 4 times 3 is 12. 12 times 2 equals 24. I will only do 2 more and I'll be done. Like I said, in class, I'll go in more in detail. You guys don't want to be in class, so fine with me. This one says, how many 3-person committees can be chosen from a group of 6 people? If I am just choosing someone and I am not giving it a value of those designations, then the order doesn't matter. Again, if I am just choosing people and I'm not giving value to the designations, that becomes the order doesn't matter. So when the order doesn't matter, isn't it called combination? So once again, I will do the combination formula. N CR. N factorial, R factorial. So what is the total number I can choose from? Well, let me see how many people they are. 6 people? 6. We'll go here. Out of those 6, how many am I selecting? Well, I'm only selecting 3. So I will replace it. 6 factorial. N equals 6 minus 3. 3 factorial. Just simplify. 6 factorial with 6 minus 3 will give me the same value. I still have this 3 over here. And just finish the thing. 6 times 5 times 4 times 3. I stop at 3 because of the 3's in the bottom. However, that's only going to take care of one of the 3's. I still got to calculate the other one. 3 times 2 times 1. 6 times 5 gives me 30. 30 times 4, 120. 120 divided by 3 times 2 is 6. 6 times 1 is 6 again. So my answer equals 20. Last one. Similar to this now. Let me look for it. That one. 100 factorial. Let's see if we can solve it. The student body of 100 students wants to elect the president, vice president, and secretary. Now I have given a value. The upcoming elections, don't you think those people want to be president? When it matters to someone, then the order matters. Someone wants to be president, someone wants to be vice president, someone wants to be the secretary. So when the order matters, I gotta use permutation. The formula looks almost the same, but it's not. It's just missing the R at the end. What's the total number I can choose from? 100. Out of those 100, how many can I select? Well, I only need 3 positions. So let's replace them. 100 factorial. 100 minus the R. So 100 factorial over 97 factorial. So just expand it. 100 times 99 times 98 times 97. Why do I stop at 97? Because of the thing in the bottom. There's no need for me to go all the way to 1. It's gonna keep going, it's gonna keep going, but every single number is gonna cancel. So I just take the number and multiply it. Just take the number and multiply it. If you put it, double check all the answers I'm giving you. 100. Equals 970, 200. Well, this is combination and permutation. Make sure you go ahead and complete my work. Again, if you're not in class and you're probably doing something that I don't need to know. Just complete the homework.